seen the difference between data, info, and also knowledge. And also we have seen when data is added with context and meaning, it will become the info and then upgraded into knowledge. So now we are going to see definition about database. So good decisions require good information derived from raw facts. Data is managed most efficiently when stored in a database, used in almost all modern settings involving data management, business, research, administration. Good decision making is the key to organizational survival. Okay. Uh, and okay, what is data management? So data management focuses on proper generation, storage, and retrieval of data. So data management berkait rapat dengan pemprosesan, okay, generation of data, cara data tu dihasilkan, disimpan dan di okay, carian data tu sendiri. Okay, what is database actually? So database can be defined as shared integrated computer structure that stores a collection of end user data and metadata. So we can say that database consists of two types of data. Okay, can be divided into two types of data, end user data and metadata. So what is end user data and metadata? So end user data refers to raw facts of interest to end user. So the one that we see just now, yes, no, numbers. So that is end user data. Okay, next is metadata. Metadata is actually data about data, okay, which refers to description of data characteristics and relationship in data, complements and expands value of data. Contohnya data tu characteristics of data, contohnya macam nombor, gambar, teks, alfabet dan sebagainya. Okay, next we move to DBMS. What is DBMS? Database Management System. It is a collection of programs which manage, structure and controls access to data. Okay, what are the roles and advantages of DBMS? Okay, it functions as the intermediary between the user and the database. Menjadi orang tengah di antara user dan database. So database structure stored as file collection can only be accessed through DBMS. Okay. DBMS enables data to be shared and it integrates many users' views of the data. Okay, we can see in this figure, we have end users. Okay, we have application requests linked to the DBMS, Database Management System. Okay, then the DBMS is linked to the database structure. Okay, consists of, okay, this is database. We have metadata, data about data. Okay, and the end user data. Okay, the customers, the invoices, the products. Okay, this database refers to a business organization. So that's why we have customers, invoices, product. Okay. Okay. So different users are linked by the DBMS to the database structure. Okay, next we move to advantages of DBMS. It improves data sharing. So we can see here in this figure, okay, many users can share the same data, okay, enabled by the DBMS. Okay, improve data security, better data integration, minimize data inconsistency. Okay, minimize data inconsistency means all the users will get the same version of data because they are linked to the same database structure. Okay, improve data access. Okay, everything can be accessed from this database structure about customers, invoices, product. So uh, it improves data access, improve decision making because everything that we need can be accessed from the same database structure, and it also can increase the end user productivity. Of course, when it improves the decision making, it improves the data access, it can increase the end user productivity. Okay, next we move to type of databases. So databases can be categorized into three types. Okay, the first one is based on number of users. Second one based on database locations. The third one based on expected type and extent of use. Okay, so now we try to see the first category. Okay, we try to group or categorize the database based on the number of users. So based on number of users, we can group it into a single user database which supports only one user at a time. Okay, for example, desktop database, okay, which is used by single user and runs on PC. Okay, you have, for example, you are sitting in front of your PC, you access to your desktop database, so only you, okay, as a single user, uh, use the database. Okay, second category under number of users is multi-user database, supports multiple users at the same time. For example, work group and enterprise database. Okay, okay, for example, this one can be categorized as multi-user database because the database can be used by different users. Okay, the next type of database we can classify it based on the locations. So either centralized or distributed. So centralized if the data is located at a single site, distributed if the data distributed across several different sites. Okay. Kalau database tu hanya disimpan dalam satu storage sahaja, it is known as centralized. So kalau dia diletakkan di beberapa tempat, it is distributed database. Okay, the next one is expected type and extent of use. Okay, so we can divide it into operational database and data warehouse. Operational database means support, which is a database that support a company's day-to-day operation. For example, transactional or production database, data harian. Okay, or data warehouse stores data used for tactical or strategic decision. Okay, data yang untuk long term. Okay, operational is day by day. Okay, next we move to the two types of data. Data can be divided into two, whether unstructured or structured data. Unstructured data means the data exists in their original state. Okay, while structured data result from formatting. Structured data adalah data yang sudah pun melalui proses formatting. Okay, structure applied based on type of processing to be performed. And then another one, we have also semi-structured data that have been processed to some extent. Maksudnya data tu diproses tapi tidak secara keseluruhan. So extensible markup language XML represent data elements in textual format. XML database support semi-structured XML data. Okay, then we can see these are types of databases, okay, and the product, okay, of database. We have Microsoft Access under Microsoft Office, okay, Microsoft SQL Server, IBM DB2. This is the one that we are going to use for our lab session, IBM DB2. We have MySQL, Oracle, RDMS, and we can see whether they support single user, multi-user, okay, and based on data location, whether it is centralized or distributed, okay, and based on data usage, whether operational or analytical, and also whether it supports XML or not. Okay, so all these except XML, except Microsoft Access. Okay, next, we are going to see the importance of database design. So in this course, you are going to learn about database design. So why do we need database design? Because database design focus on design of database structure used for end user data. So designer must identify database expected use. So of course, bila you nak design satu-satu database, you must know the expectation of the end users use. So well-designed database, what are the criteria of well-designed database? It should facilitate data management, menyenangkan pengurusan data, generates accurate and variable information. Okay, can help the end user to generate accurate and valuable information. Maklumat yang dihasilkan tu mestilah tepat dan berguna untuk organisation kebiasaannya. Okay, poorly designed database could cause difficult to trace errors. So kalau database tu tidak design dengan baik, dia akan menghasilkan difficult to trace errors. Okay, masa nak buat carian dan sebagainya. Okay, next, file system. You have to know what is file system. Okay, file system typically composed of collection of file, folders, each tagged and kept in cabinet, organized by expected use. Okay, before we go into details about database, you have to know the concept of file system. Okay, file system biasanya kita tengok file diletakkan di kabinet. Okay, disusun mengikut kegunaan. So contents of each file folder are logically related. Okay. Reasons for studying file system. Complexity of database design is easier to understand. Understanding file system problems helps to avoid problem with BMS. And knowledge of file system is useful for converting file system to database system. So file system ni adalah manual file system. Okay, jadi untuk memahami kegunaan dan mengelakkan masalah dalam DBMS, kita perlu faham konsep file system terlebih dahulu. Okay. So evolution of file system data processing. So file system actually begin with manual file system, serve as a data repository for small data collection, cumbersome for large collection. So kalau you tengok manual file system, kalau ada data tu semakin banyak, dia akan jadi cumbersome. So it has been upgraded to computerized file system. So data processing specialist converted computer file structure from manual system. So kalau di kebanyakan organisasi sekarang ni dia dah beralih arah daripada manual file system, dia dah jadi paperless kepada computerized file system. Okay, wrote software that manage the data, design the application programs. Okay, still in the evolution of file system data processing. Initially, computer file system resembled manual system. Okay, pada awalnya computer file system ni dia menyamai manual system yang based on paper. As number of files increase, file system evolve. So samalah macam konsep kertas. Semakin banyak file, file system tu akan bertambah. Okay. Each file use its own application program to store, retrieve and modify data. Each file was owned by individual or department that commissioned its creation. Okay. Next, okay, let's try to see. This is an example of customer file. Okay, contents of the customer file, we have customer name, customer phone, customer address, customer zip, then the name. Okay, customer name, first name, and this is the agent name, agent phone number. Okay, insurance type. Okay, this is for the insurance company. Example of customer data for an insurance company. Okay, amount of insurance taken. Okay, and the renewal date. Okay, so we are going to see the basic file terminology. Okay, we have here data. Okay, as I said previously, data means raw facts such as telephone number, birth date, customer name, year to date, sales value. The data have little meaning unless they have been organized in some logical manner. So if you see here, Alfred A. Ramas, okay, is considered as a data. Okay, 36123 also data. T1 also data. Okay, 5 April 2012 is data. Okay, next, field. A character or group of characters, alphabetic or numeric, that has specific meaning. A field is used to define and store data. Okay, where is field here? Field is, for example, the C name. Okay, the customer name, C name is the name of the column is field. Okay, C phone, C address is what we call field. Okay, then record. Okay, what is record? A logically connected set or of one or more fields that describes a person, place, or thing. For example, the fields that constitute a customer record might consist of customer name, address, phone number, date of birth, credit limit, and unpaid balance. Okay, where is the record? Okay, record is everything about, for example, Alfred A. Rama, 651-844-2573, 218 Fog, and so on. Okay, the whole row, okay, keseluruhan baris ni adalah one record. Okay, Leona K. Dunn, and the rest of the field here. Okay, so, the whole row here, keseluruhan baris ni adalah satu field. Okay, we call it field. And then file. What is file? A collection of related records. For example, a file might contain data about the students currently enrolled at Gigantic University. So everything here, the whole table, we call it file. Okay, this is a figure showing simple file system.